Let's make progress. Number 23. Convert 11010110 base 2 to denary. Denary is another word for base 10. Okay, we are still dealing with base 2 numbers. Now, just like we deal with place value system in base 10 numbers or natural numbers, we also deal with place value systems rather in other number bases. In this case, we start with 0. We don't use unit, tens, 100,000. We simply just number them using counting numbers including 0. So we have 0 as the one for the last digit, then 1, then 2. So you number them to your left. What are the usefulness of these numbers? We use them to simply code the interpretation of each of these digits in base 2. And how does that work? Now look at this. Since the place value for this first one is having this 6 code, we simply multiply 1 by 2, because we are working in base 2, raised to the power of this 6. We do the same to the next number. 1 times 2 raised to the power 5, 0 times 2 raised to the power 4, 1 times 2 raised to the power 3, 0 times 2 raised to the power 2, 1 times 2 raised to the power 1, and then 0 times 2 raised to the power 0. We do this because we are working in base 2. We are working in base 2. And these numbers that are powers are used to establish their place value. Now, what is 2 raised to the power 6? That is 2 times 2 times 2 times 2 times 2 times 2, and that gives us 64. 2 raised to the power 5 will give you 32. 2 raised to the power 4 will give you 16, but 16 times 0 is 0. That's why you're having 0 here. 32 times 1 is 32. That's why you're having 32 here. 64 times 1 is 64. That's why you're having 64 here. Okay. 2 raised to the power 3 is 8. 1 times 8 is 8. 0 times 2 raised to the power 2 will still give us 0. 2 raised to the power 1 is 1. So 1 times 2 is 2. And then 2 raised to the power 0 is 1. 0 times 1 is 0. When you add up all of these numbers, we get 106. 106 is the number in base 10, which when written in base 2 will give us this number. Okay,